Okay, so welcome to the week 8 webinar. And the good news is we're online. So unlike the rest of the entire college, we can still do some statistics. Whereas my face-to-face class, you guys, you know that we didn't have class today because the college is closed. And the college, just to let you know, the college is closed, was closed today. And the college is also closed tomorrow because same reason we're supposed to continue this blizzard for another day. And then might come back next week, hopefully not too bad. But just let you know, the college is closed tomorrow. So that means if you try to come to the college, you won't get there. And the roads probably won't even be good enough to be able to get anywhere anyway. So it's a good day if you're in Tahoe to just stay home because it's dangerous to be out there in the snowy road. So let me talk about the plan today. We are moving into chapter 10. So I'll start out with Q&A as always, and then we'll talk about chapter 10. The good news is that if you understood chapter 9, there's very little new stuff in chapter 10. The bad news is if you're totally lost on chapter 9, you need to get found because chapter 10 is basically a repeat of chapter 9 with a couple little extras. So let me tell you the pieces of chapter 10. So chapter 9, just to remind you, was about hypothesis testing for a proportion or for a mean. And just note chapter 8 was about confidence intervals for a proportion or a mean. They come up sometimes, but more often, you actually are not just seeing whether a mean is bigger than some number or a proportion is bigger than some number. You're actually doing a comparison. You want to find out, hey, was last year different than this year? Or is that other guy worse than me? Okay, or are things different on the East Coast than they are on the West Coast? Those are the kind of things you want to look at. Or maybe do people, spend more time brushing their hair than they do brushing their teeth? So those are the kind of things that we'll be looking at. So we'll be having 3 different confidence intervals and hypothesis tests. We're going to kind of, once you've done one, it's easy to do the other. And the first will be a hypothesis test in the confidence intervals for the difference between 2 proportions. So that might be, the proportion of Hispanics. Are they any different than the proportion of Caucasians in terms of, I don't know, having a passport? Who knows? Okay. But anytime you want to find out the difference between 2 proportions, we'll be able to do that today. Then we'll talk about a hypothesis test and a confidence interval for the difference between 2 means when they're independent. And I'll spend a lot of time today talking about what it means to be independent versus dependent. So we'll also look at a hypothesis test and a confidence interval for the difference between 2 means when they're dependent. And again, that's right now, I don't expect you to really know the difference, but I do expect you to know the difference at the end of this webinar, because that's a big piece of it. Then what we'll do is project 2. We'll talk about project 2. Project 2 is all about chapter 10. Because as I mentioned, comparing 2 things is much more important than just looking at a single and in terms of how things work. So that's why I'm, making project 2 that. Also, it's either going to be this 3 or 4. It's going to be a hypothesis test and a confidence interval for the difference between 2 means. You can choose whether they're independent or dependent. And the main reason for that is sample size. To have good sample sizes, if you're doing proportions, you're going to need like over 1,000, and that's not good. I mean, you don't want to do that. I don't want to, I'm not here to torture you. It may seem like it, but I'm not here to torture you. Okay, so that's why I'm going to have you do 2 means, because over 30, you usually have pretty good data. You can get that normal distribution always, and the margin of error is small enough that you can actually have something to talk about. If you have 35 and you're doing a proportion, the margin of error is usually huge and not worth it. So that's why I'm going to make you do means. And we'll be talking about all the details of the project. So that is the plan today. We're getting towards the end. I don't know if you're seeing it or feeling it. We're in week 8 out of a 12-week class. And week 12, there's not much in week 12. There's a quote unquote final exam, but really it's just a regular exam. So really there's 8, 9, 10, 11. Okay, so those are the weeks. And we'll do a chapter a week. And each chapter is actually really important and used a lot. So that's why 1 chapter a week, and we're going to focus on this. And used in the real world is what I mean by used. Okay, and in fact, I'll be showing you some real world stuff. One is an article, and the other is going to be how I made a lot of money once. And I'll show you that and give you my own historical, piece on making money when no one else noticed the statistics. Okay, and it wasn't by teaching statistics. It was something else, and you'll see. Okay, are there any questions about anything? And hopefully we don't lose it. If all of a sudden you don't see me anymore, our electricity's out. We're having a blizzard, so let's hope that doesn't happen. Okay, electricity or internet. But so far, I'm crossing my fingers, we haven't lost it today. And by the way, my office hours, I should mention this, tomorrow will be online because the college is closed. And you're online students anyway, but just to let you know, I will not be in my physical office because I'm not allowed in, even though I can get there because I have a better vehicle than anyone to get there. I ski to work. I can ski, but I can't get in because the door's locked. And I don't have a key to the main building. So just to let you know, so my office hour, I'll be on Zoom. And if you try to get on Zoom and I'm not there, that means we have no internet or electricity. That could happen tomorrow. We got more blizzard tomorrow. Okay, so any questions about anything? Any questions? Okay, if there's no questions, let's go talk about confidence intervals and hypothesis tests for the difference between 2 proportions. So let me scroll up a bit. And I grab one that is realistic. So the question is, do a lower percent, I guess does a lower percent of Americans this year think that inflation is the most important problem today compared to last year? Okay, so, hopefully, we're in the midst of inflation, more inflation than for some of you in your lifetime, but not more in my lifetime, by the way. We have had more, but inflation is pretty bad. And is that the top problem in America right now? And not is it the top problem, but is it a bigger problem, according to how people think, than last year? Because last year it was a problem too. And what I did is I went to Gallup. Gallup is, for me, it's a nice news thing because I can get information that I couldn't get in a lot of the places. And let me hit that hide button. There we go. And it says, the government is a top problem. Inflation ranks second. But if we go here, 16% last year thought inflation was the biggest problem in America, and 15% this year. So if you look at those numbers, 16%, 15%, which is a bigger percent? Hopefully you can all know that. That's easy. Which is bigger? You can pop in the chat or whatever, or say it.
16.
Yeah, 16%. Again, there's no formal prereq for this class, but hopefully you know that 16% is bigger than 15%. So does that mean that last year was bigger than this year for the percent of Americans that think inflation is the worst problem in America? And hopefully we're far enough into the class that you have a good answer for this. So can we say that last year was worse than this year in terms of, you know, a higher percent of people thought inflation was worse last year, or the number one problem, than this year? Any thoughts? Hopefully you can say it or put it in the chat box. It's always good if you can participate. And just want to remind you, because I know especially if you happen to be from the face-to-face class, I do record this, I put it on YouTube, but the chat box does not put on YouTube, so that's confidential. But that your voice, if people recognize your voice, that will be heard, not confidential. Who you are is confidential, but okay. Yeah, it looks like more last year, but here's the thing. I know for a fact they did not ask everyone in America. How do I know? Absolutely, I am completely sure. My guess is you probably are also. Yeah, no one asked me. And let me ask, did anyone ask you? Okay, I've never had a student say yes. Because there's a lot of people in America. And they only ask, you know, a little over 1,000 usually. All right, so what we can do is we can form a hypothesis test. We don't know the percent of all Americans last year. We don't know the percent of all Americans this year. So we're comparing two proportions such that we don't know either's population proportion, but we know both of their sample proportions. Do you see how that works? And we have not had that kind of question in this class yet. So it's the first time we're approaching this. We have two proportions. We sampled for both of them, and we don't know either population. So we cannot do a hypothesis test for a single proportion. What we're going to do is we're going to do a hypothesis test for two proportions in comparing two. Any questions on that idea? All right, so now let's do it. So I'm going to go back. And I could have shown you where it said on the bottom the number of Americans last year and this year. Last year, actually, I had to go last year. But this year they surveyed 1,011. I guess I should write this year. And 1,024 were last year. Okay, this year 15%. Last year 16%. And what I'm going to do is I'm going to write down, and hopefully you're used to this now, the null and alternative hypotheses. Okay, we've never seen this exact thing before, but I don't think there's any surprise. It's still H naught, still a colon. I wrote P sub 2023. That is the proportion of all Americans who think that inflation is the top problem in the United States in 2023, this year, is equal to the proportion of all Americans who think that inflation is the top problem, and that for last year, who thought, I guess would be a better word, because it's last year. Any questions on H naught? Okay, H1, so I write H1 colon, still have the proportion, population proportion of those who think that inflation is the top problem in America. But now H1 is that is less than, because we want to see if this year is less than the population proportion of all Americans last year who thought that inflation was the top problem. And that's a less than. So same old stuff that we've had before. Sometimes you'll see a less than, sometimes you'll see a greater than, sometimes you'll see a not equal to. And it really depends on what you're serving, what you're interested in. My question was, is this year less than last year for the percent of Americans who think inflation is the top problem? Okay. And this is probably, sociology kind of thing. So 5% level of significance, standard. Any questions on this? Okay. If you look at, let's say, the type 1 error is that Gallup would put in the article that, hey, this year is not as bad as last year for people thinking about inflation, but they were wrong. And that's pretty bad. No one's going to die or anything, but, it makes them look bad. Whereas a type 2 error would be, they're not able to say that. They still have the 15 and 16% there, but they're not able to put it in their article. Does that make sense? When it was really true in the first place. That's bad for them too. Kind of similar bad. This is one of those is neither are that bad. Is that clear? Okay. No one's going to die or anything like that. But yeah, it doesn't make you feel good if you publish something, in the news and you're wrong. Any questions on the level of significance? Okay, p-value. So now we need the p-value. So I'm going to go to the calculators. And which calculator do you think I need to use for this hypothesis test and confidence interval? We're going to do both, actually. Even though it's
19.
Yeah, so it's going to be 19. Yeah, so 2 proportions. Okay, notice I didn't write hypothesis test because it's both hypothesis and confidence interval on this one. So let's click on 2 proportions. And again, stop me if there's anything that doesn't make sense. I'm trying to make the calculator obvious, but if it's not, let me know and I'll make it more obvious. But you have to tell me how. All right, so now what it says is first sample, second sample. The first sample is 2023. And if you remember, or if you look again, in 2023, there were 1,011. Okay, this year there's 1,011 that were surveyed. So I'm going to go to 1,011. The second sample, that was the year 2022. And that was 1,024. So I'm going to go to 1,024. Any questions on that? Okay, I need to find the number of successes. And remember, a success is just a yes answer. Nothing doesn't mean it's actually a good thing. Just means that the person said yes to the survey question. And the survey question here, by the way, is, do you think that inflation is the #1 problem in the United States? And the answer is going to be yes or no. And that's why this is proportions. Any questions on that? Looking at the survey question and seeing its proportions. Okay, so now the number of successes. If we see for, again, this is this year and this year, it was 15%. So what I'm going to do is I'm going to go down to the scientific calculator, and I'm going to find 15% of 1,011. 1011 times 0.15. I'm going to round to the nearest whole number because, again, 0.65 people can't say yes. So you got to round. So 152. And then I'm going to find 16% of 1,024. So 0.16, and it's 1,024. And I get about 164. Any questions at all on coming up with the numbers, this 164? The number of yeses or number of successes. Anytime you have a proportion, you need to round because you can't have a fractional yes answer. So it's not about people. If it was a survey question or something like I don't know, are dogs more likely than cats to run away? Well, a 0.62 dogs can't run away. Does that make sense? Yeah. So with proportions, you're always going to round to the nearest whole number and just use the rule of rounding. Okay, so now in our hypothesis, and I'll go back to look at it. There we go. We have proportion for 2023 is less than the population proportion for 2022. So we want to make sure that we click on less than. Any questions on that? Okay, confidence level. And I'm gonna explore this a little bit, but again, this is sociology. What do you think a good confidence level might be for sociology?
%5.
5% would be a good level of significance, but not a confidence level. Because that would mean you're wrong 95% of the time.
95%.
Yeah, probably 95%. Okay. Does that make sense?
Yes.
Okay, and then I hit calculate. Okay, and by the way, I'm not going to get into the hard math, which I try never to do, but the normal distribution is what you're going to use. And that's you'll trust me, it works. It's kind of an advanced central limit theorem. Our p-value is 0.27. Okay. Is that small or large? .27.
Large.
Yeah, that's a large p-value. Okay, remember we're comparing with 5%. This is 27%. Okay, but actually, even if we went to 10%, which would be, very high level significance, it's still larger. Do you see that? So the p-value is 0.27. So the good news is it's the same old stuff that we did last week. There is statistically insignificant evidence because our p-value is greater than our level of significance, and that's when you have insignificant evidence to conclude that the proportion of all Americans this year who think that the inflation is the number one problem is smaller than. And I should say population proportion, sorry. You can get away with proportion because I said all Americans, but I'm going to double say it. Then the population proportion of all Americans last year who thought that inflation is the number one problem. Doesn't it feel real similar to what we did last week? Right. The big difference is now we're comparing two things at which we don't know the population for either. We only know sample. That's the new thing. Okay, we can interpret the p-value, and that's going to be very similar. So that is if the, and I'm going to copy and paste what we're looking at. Population proportion of all Americans this year who think that inflation is the #1 problem. And I'm going to take is smaller than, and copy and paste. I love copy and pasting. If the population proportion of all Americans this year who think that inflation is the #1 problem is the same as the population proportion of all Americans last year who thought that inflation is the #1 problem. And if we surveyed another, and it was 1,011 this year and 1,011 Americans this year, and what was it, 1,024, I think, wasn't it? Yeah, 1,024 last year. Which is hard to do, hard to survey someone last year right now, but we could do it in theory at least. Then there would be and now we can look at it. Our p-value was 0.27, right? If I remember right, yeah, 0.27. There would be a 27% chance. By the way, not a 0.27% chance. I noticed on the discussion post, some people forgot to change that to percent. So it's a 27% chance that the new study would result in, and notice that there was 16% this year, 15% last year, so 1% fewer this year than last year who thought, I guess, that inflation was the #1 problem. Doesn't this look a lot like last week too? Okay, so as I warned you or told you, is that this week is not much different than last week. The hard part is, towards as we go on, you have to decide which kind of hypothesis test is it. Is it 2 samples? Is it 1 sample? Is it proportion? Is it mean? And we're going to have more and more of them as the course goes on. So that's just a note. You should always be looking at how many samples. Is it the survey question yes, no? Is the survey question quantitative? Interpret the level of significance. So the good news is I can copy and paste, just like I told you last week, all the way up to there would be a. So the population proportion of all Americans this year who think that inflation is the #1 problem is the same as the population proportion of all Americans last year who thought that inflation is the #1 problem. And if we surveyed another 1,011 Americans this year and 1,024 last year, then there would be a. Now it's not a 27% chance. What percent chance? We're interpreting the level of significance.
Was it 5 or 95?
5%.
5.
5% chance that the new study would lead us to falsely conclude that, and now I'm going to copy and paste. The population proportion of all Americans this year who think that inflation is the #1 problem is smaller than the population proportion of Americans last year who thought inflation is the #1 problem. So the good news is lots of copying and paste. And one good thing about an online class, by the way, sorry, you're a face-to-face student who's here, is everything's online. You're always able to copy and paste. So it's not as much typing as it looks, even though it's a really long paragraph. But copy and paste works. Any questions at all on the hypothesis test? Okay, let's look at the confidence interval. I want to go back. So 95% confidence interval is this guy. Okay, one of the things you might say is maybe 95% is not great because, hey, it doesn't tell us which one is more, because it could be less or more. Do you see that? So sometimes you want to explore and maybe try 90%. See if that's any better. And the bad news is we still don't know who's more. You could try 99%. And then it's even a wider margin. So I'm probably going to go for the 90%, 95%, because none of them are great. So if might as well go for the standard. Okay, but sometimes one's better than the other. Okay, so for example, if these became both negative, when I went to 90%, I'd probably go for the 90%. Because then I could be 90% confident, and then I'd say this one's smaller. Do you see? On the other hand, 95%, you may not be able to. In this case, you have negative and positive in any case. Okay. Whereas if they were both negative in all three cases, I might go for the 99. Because then I can be very confident, you see? But I'm going to look at negative 0.05 to 0.03. Okay, I'm going to round to the nearest whole percent, basically. So negative 0.05 to 0.03. So let's write that down. So the confidence interval is negative 0.05, comma 0.03. And now for interpretation. So it's going to be the same idea with 95% confidence. Remember how we had those words before? Nothing changes. Okay. The population proportion of all Americans, capital Americans, who think that inflation is the number one problem, is between 5% less, negative 0.05, you can think of as 5% less, and 3% more than the population proportion of all Americans who thought that inflation was the number one problem. Oh, do you know what I forgot to write? This year on the first one. Number one problem last year. Because we're comparing this year to last year. Any questions on the interpretation of the confidence interval? Any questions? Okay, so that's an example with proportions. Was there anything that's like really different? Okay, there actually is something really different, but not that you're ever going to notice. Any guess? The math. the deep inside the calculator. There's some tough math that happens, but I'm not going there. Sound good? So you never have to worry about that. But what you do have to know is which kind of confidence interval and which kind of hypothesis test are you doing? Is it proportions? Is it means? Is it one sample, two samples? Okay, so next, let me do another example. Okay, so this example is the following. Do single women spend more time cooking than single men? Okay. The 35 single women who were surveyed averaged 58 minutes a day cooking, and their standard deviation was 12 minutes. Just by the way, to let you know, I made these numbers up. So don't like quote me that you heard about America or something and there was a big survey. But a survey could have been done. Okay, but I figure, especially since I'm posting it on YouTube, let you know that these numbers are made up. Okay, the 38 single men who were surveyed averaged 46 minutes a day cooking, and their standard deviation was 16 minutes. What can be concluded at the 5% level of significance? Also interpret the confidence interval. All right, so first thing, what's the survey question?
A mean?
Yeah. Well, what's the question though? What's the survey question?
Oh, like quantitative or qualitative?
I want to hear the question in words. The whole, what would you ask this person?
Oh,
It's not supposed to be hard.
do you spend more time cooking than single men? Do women spend more time cooking?
Aha, I like what's in the chat box. How many
Okay.
minutes a day do you spend cooking? That would be the survey question. Does that make sense? And the answer, I might say I spend 58 minutes a day cooking. So I wouldn't say yes. Do you see? The answer to the survey question is a number. Okay. I want to mention a few really important things. One, they asked 35 single women and they asked 38 single men. Do these men and these women have anything to do with each other? Yeah, they don't. Okay. Had they asked, let's say they asked 35 couples, men and women, who are not single, and we wanted to look at single. If we didn't want to look at single, we want to look at couples. Then they do have something to do with each other. They're paired up. Do you see that? Okay. And then we would have dependent data. Or if the survey question instead, if they asked women, let's say, or they asked people, hey, how much time do you spend cooking for breakfast? And then they asked, how much time do you spend cooking for lunch? And then it would be one person answering two questions. That would be dependent also. Okay, because that would be paired up in a way. Whereas these are not dependent at all. These are independent. If you switch the order, you haven't changed anything. Any questions on seeing that this is independent? Oh yeah, we're definitely doing dependent. We'll do one of each. That's the plan today. Yeah, so I promise. Yeah, we will do independent, dependent. So there are three main types. I'm gonna do one of each type. Okay. And the third one is my favorite, actually, for a good reason that I'll explain in a bit. Okay. Not my favorite because dependent is better, but you'll see. You'll totally understand why it's my favorite. Okay. So because they're independent, I'm going to have H not colon, always have that, no matter what it happens. And then you're going to have mu sub W equals mu sub M. So that's the mean time cooking, population mean time cooking for women is equal to the population mean time cooking for men. Okay. And H1 colon is mu sub W is greater than mu sub N. The population mean time cooking for women is greater than the population mean time cooking for men. Any questions on that? Okay. We want to use a 5% level of significance. Sounds like a good one. So to do that, let's go back to our calculator. Let me hit that one. And which calculator do you think we're going to do? What number?
Number 18.
Yeah, number 18. We have independent samples. Okay, and we have statistics. We don't have data. Okay, so we have the sample sizes. So it kind of looks like similar to last. It's not the same, but at least it started the same, the two sample sizes. So let's go find those sample sizes again. There were 35 women and there were 38 men. So 35, 38. The sample means for women were 58 and for men was 46, 58 and 46. And then the sample standard deviations for women was 12 and for men was 16. Any questions on getting the numbers into the calculator? Okay, so now they've done that, I have to decide, is it less than, greater than, or not equal to? And I can go back, look at this, and I see a greater than sign. So we click on greater than. And maybe I'll try a 0.95. Just a note, unlike the level of significance, you must decide before you even collect the data. Confidence level, you can decide afterwards. Okay, that has to do with more of like honesty. You know, it's just bad. It's just bad to karma to pick the level of significance after you've looked at your data. You're not supposed to do that. Okay. But confidence level, you are. And hit calculate. Okay. My test statistic is now T. Because, by the way, we didn't know the population standard deviation, that T was to adjust for that. The p-value is 0.00026 about. What does that tell us if the p-value is 0.00026? Same as last week, by the way. Yeah, reject the null hypothesis. So that means there is statistically significant evidence. And I'm going to write strong. And I want to mention this is really important. It's only strong if you're less than 0.01. Don't use the word strong unless you're less than 0.01. If it was 0.04, don't say strong because that's not strong evidence. Okay, and typically if it's like 0.07, then you usually say weak evidence. Okay, whereas if it's say 0.03, you just say there is statistically significant evidence and you don't have any kind of adjective in front. And that's especially important because a lot of times you don't even like have a level of significance. You just use those words to say what it means. And you'll see that in literature a lot. So there's strong statistically significant evidence to conclude that. And the good news is all we have to do is state H1 in words. So this says population mean cooking time for women is greater than population mean cooking time for men. And I'm going to write single woman. Cooking time for single woman is greater than the population mean cooking time for single men. Any questions on that? Is that clear? Okay, so now let's take a look at the, oh, I didn't put it here. Let's put it here, confidence interval. Yeah, strong. You use the word strong if it's less than 1% or 0.01. Use weak typically if it's between 0.05 and 0.1. If it's greater than 0.1, you just say it's insignificant. Any questions on that? And that's just standard. I'm not making it up, I promise. So the confidence interval is one of those we can look at now and decide. So 5.4 minutes to 18.6 or 5 minutes to 19 minutes. Is that enough information to have a good range? What do you think? We can play around. We can try 99%. That'd be 3 minutes to 21 minutes. And you can try 90%. And that's 6.5 minutes to 17. So 7 minutes to 17 minutes. Which one do you think is better? And that's one of those for feel, you know, because remember, being 90% confident, that means you have a better chance of being wrong with this interval. Being 99% confident, you have a better chance of being right, but the interval is wider. Do you see? So you have to decide, you know, which works better for you. And I'll let you tell me what you'd like to have. And 95, that would be somewhere between 5 and 19 minutes, and your 5% chance of being wrong. And just a note, before you even start, there's always, if you have a 95% confidence interval, there's a 95% chance of being right. Doesn't quite work that way once you've actually taken the data, and then it gets a little weird. That's why you have to do the long sentences. So what do you want to use? I'll let you choose. First one to pop in the chat box or say it is the one I'll take. 90, 95, or 99. And those are the standard three. Okay, 99. So we use a 99% confidence interval. And I'm going to go by, I can go closest, nearest minute, probably what most people care about. Most people don't care about how many, like whether someone spends, you know, 3 minutes and 20 and 20 seconds longer versus 3 minutes and 30 seconds longer. It doesn't, most people don't care about that. 3 minutes. Okay, so 3 minutes to 21 minutes and 99%. So interpret the confidence interval. And that's, remember the first word. What's the first word? Always for confidence intervals. Y'all remember? Yeah, with. 99% confident. We're very confident. The population mean time single women spend cooking is between 3 minutes and 21 minutes more or longer probably than the population mean time men spend cooking. That does not mean that all women spend more time cooking than men. It's a population mean. It's not about individuals. Any questions on this example? Okay, you ready for my favorite example? Okay. And by the way, it may feel political when I talk about it, but I'm not getting political. But it is something that happened. And it happened about 5 years ago. And one of the things I do a lot is I watch the stock market. Okay. Any guess on why I watch the stock market? Should be an obvious answer.
Because you're invested in the stock market.
Invested and more important, investing. I want to make money. Isn't that a good reason? So I want to make money. And what I look for is I look for patterns. And I look for patterns that other people have not found. And if I can find a pattern that other people haven't found, I can make a lot of money. Does that make sense? And I use statistics to do that. And what I've learned is that if all I look is the numerical patterns, I have no chance because AI does better than people. So what I do is I look at the combination of politics and the statistics. So let me show you what I found about 5 years ago. What I noticed, and you may or may not remember, who was our president 5 years ago? I hope you remember that. Whether you liked him or not, you probably remember. Uh-oh, I don't see anyone answering.
It was Trump, right?
Yeah, it was Trump. Okay. One of the things Trump did, and again, what I never do in class is tell you whether Republican or Democrat is a good thing. That's up to you. And I don't try and tell you how to be a politician or, what politics you should like. But I do want to tell you how to make money. And that is you look for patterns, whether it's Trump or Biden or whatever. And I noticed that Trump often tweeted about China. I don't know if you remember those old days, but he used to tweet a lot about China. I'm gonna put a big tax on China. I got to get them. And it doesn't really matter in terms of what I'm about to say, whether you were happy or sad about that. What matters is, were you recognizing what was happening to the stock market after the tweet? And what I noticed is the stock market went down after the tweet, but then it always came back up and it just popped down and up, down and up, down and up. So then I looked and I tried to find a stock that reacted, basically one of the most strongly of stocks that I trusted at the time. So here's what I did. And I even made a name for it. I made this up, by the way. This is not a statistics word. I called it playing the tweet. So what I looked at is I found now, anyone know what this is, NVDA? NVIDIA. Have you heard of that? Okay. So it's okay if you haven't heard of it. Have you heard of Intel? No, like the company? Okay, so NVIDIA is one of the big competitors to Intel. They make chips. Okay, so they make chips. They do a few other things too, but their main thing is making chips. Computer chips, by the way, not potato chips. So what I noticed is that they seem to react a lot. So what I did is I looked at 6 different tweet days and 1 week later, and I looked at the stock price for NVIDIA, tweet day and a week later. And these are the numbers I got. Okay. By the way, there was a reason why I did not get a sample size over 30. Anyone guess? A week stays? Not sure what you mean by that. Okay, the reason is that if I waited until he tweeted 30 times, then it's going to take a long time, like a year or two, and then he won't be in office anymore. And I can't make any money. So I need to get this going. Does that make sense? That was the reason. Not sure what a week stays meant, but that was the reason. So I did a small sample size and I had to. Okay. So then the question is, so we need to assume, by the way, the distributions are approximately normal. We look at this and I want to create a hypothesis test and a confidence interval. So I want to look at the tweet day versus a week later. And the idea is that tweet day is lower than a week later. That's what you call buy. Hopefully you've all heard this. You should always buy when it's low and sell when it's high. You've heard of that? So that's what this is, because I want to buy on tweet day and then sell a week later. Okay. Now, are these dependent or are these independent?
Dependent?
Yeah, these are dependent because this 106 and 113 go together. This was 106 on that day that he tweeted, and then it went up to 113 a week later after that day that he tweeted. Do you see? You can't say 110 and 113 because those don't match. They're not paired. The pairing happens on tweet day versus a week later for each tweet. Do you see how that works? So this is dependent data. This is an example of dependent. Very different than independent in terms of doing the, finding a p-value. Okay. So what I want to do is I want to find my hypotheses. So I need to make it pretty. H naught, colon. So now this is going to be different than when we had independent data. So what we're looking at is we're looking at the difference between a week later and tweet day. So the first letter of the word difference is D. Hope you all know that. Okay, it's still a mean. This is, hopefully you can see that these are numbers, 106, 110, 115. So it's means, not proportions. And it's mu sub D. So the mean difference equals 0. So if the tweet has nothing to do with the stock, then the mean difference should be 0. Do you see? No change. And then H1 colon, and that is going to be mu sub D. And then I want to make money. So what am I hoping the stock does?
Go up.
Increases.
Up. Okay, so if I do tweet day minus a week later, I'm going to have a negative number. Do you see? Any questions on that? Okay, so now let's go back to the calculator menu. And which one do you think I want to use?
17?
Not 17 because we don't have independent samples.
Oh, 20.
20. Yeah, there's going to be 20. So it's 2 dependent samples with data. Any questions on that so far? Okay, so now I need to put my numbers in separated by commas. So 106, 110, I think the easiest way is to copy here and then put commas in. I think it'll allow me. Yeah. So then I'll put commas. 106, comma 110, comma 115, comma 122, comma 114, comma 116. Okay. And the interesting thing, these are real. And I did notice that it kind of went up and down. If you just looked at, the day of the tweet, there wasn't any pattern. It's not like it kept going up. But if we compare the difference, everything changes. $113, comma 124, comma 120, comma 118, comma 127, comma 128. Less than what I want. How about a 95%? I'm going to go 90. My sample size is small. If I could be 90% confident I'm going to make money, I'm pretty happy. Do you see that? I might lose, but I call this play money. So if I lose, I'm not going to lose my house or that kind of thing. So this is just money that if it goes up or down, it's not going to kill me. So 90% confidence level. Whereas if it wasn't play money, I might go for the 99%. Do you see? And infinity. Oh, you know what the problem is? Forgot the decimal point. There we go. I do that sometimes. Hopefully, if you do it, you'll find out just like I do and fix it. That's the most important thing. Okay, look at the p-value. Is that small enough for me? Yeah, this is play money. If this weren't play money, if this was, say, money so that I could pay for my daughter's college education, I'd want a really low p-value. I'd have a much lower level of significance. But with play money, I'd probably go 10% for my level of significance. Do you see? Because it's not as important, in terms of losing. Because I lose if, I'm not making any money if I blew it. Do you see? And I have a lower bound and an upper bound. So our p-value is 0.018. So I could say there is, can I say strong statistically significant evidence? Not this time, because I got 0.018, which is bigger than 0.01, but there is statistically significant evidence. To conclude that the population mean value of NVIDIA is higher after the 1 week after the tweet. And I guess after the tweet, and maybe instead of value, probably price would be a better word. Than on the day of the tweet. Okay, so based on this, by the way, what do you think I did?
earned money?
Yeah, well, not just earn money, but I put in about $2,000 or $3,000 every time a tweet happened after this. I waited a week and then I took it out. And then I waited until the next tweet. And then I did that over and over again. And the interesting thing, no one caught it. Like, you know what I mean? Because if the whole world, if the whole nation found out about it, that this was happening, then this wouldn't happen anymore. Do you see? And it turns out, and this is a real thing, I did it until the impeachment happened and Trump stopped tweeting about China. Didn't even make the news, but I noticed because all of a sudden I couldn't invest anymore. And I took like $5,000 and turned it into about $20,000 so a huge increase. Yeah, so big day. I should have put $100,000 in, but then of course, you know, I could have been wrong. And then I'd lose everything. So that's how I day trade, is I look for patterns. And I found it's probably happened about 4 or 5 times in my life, actually. I found patterns that other people didn't find, made money until people found it, or the pattern stopped, and then kept looking for the next pattern. I'm looking now. So something to do, and make a lot of money out of it when you do it. Any questions at all on this conclusion? Oh, so the way mu D, maybe I'll write this out if you're confused. Where mu D is equal to, I'm going to write tweet day minus 1 week later. And that's how I created the calculator, by the way. It's the first minus the second. So what I like to do is notice, I think that 1 week later is bigger. So notice the 113 is bigger than 106. That one worked. And if I take 106 minus 113, I get -7. So that means I get a negative number, and that's why less than 0. Does that help? I like to look at an example that actually works in what my mu sub D is and what I want. And that will give me whether it's a less than, a greater than, or not equal to. Did that help? Yeah, so if I wanted it to be smaller, I don't know why I want my stock to go down, but if I wanted it to be smaller, then it would be greater than instead of less than. So this example wouldn't ever work, but let's say you wanted to show that some medication helped decrease blood pressure or cholesterol, maybe. Okay, so if you want it to get smaller, then you'd have a greater than when you have the first minus the second. Okay, any other questions about that? Notice, by the way, I'm going to carry 2 decimals for my confidence interval because that's dollars and cents. 1342, 224, and negative. Okay, so the p-value and the hypothesis test gives you a suggestion on what to do, but the confidence interval gives you more information. It actually tells you not just that the stocks goes up in a week, but how much it goes up. Do you see? So it gives you more information. So we can say with 90% confidence, the price of NVIDIA goes up. And I should say the population mean price of NVIDIA goes up by between $13.42, or how about $2.24 and $13.42 from tweet to 1 week later. Any questions on that?
Do you just ignore the negative signs?
No, I didn't ignore the negative sign, but I noticed that if it's negative, that means the second is bigger than the first.
Okay.
So what I did is I took that and turned it into words that made it a lot easier to understand. Nobody says my stock went up -$5. I mean,
Yeah.
that's just not how you talk. Does that make sense?
Yeah.
Yeah. You don't say, oh, it was -$5 higher when I started than when I sold, or when I bought than when I sold. You don't say that. Do you see that? Because that's what it is, you know, technically, but that's, no one would say it. It would just confuse the hell out of everyone. Do you agree? Any questions on the confidence interval interpretation? Okay, so I want to let you know, this is good enough for like the exams. It's good enough for understanding the assignments. This is not good enough for the project, which is what I'm going to talk about in a minute or two. For the project, you don't just want the one sentence. You're going to write a whole paragraph on, okay, then what do we do? We're going to buy, you're going to, you know, 90% confident. That's probably enough to make a good investment. But if, you know, if losing money is going to involve you going to jail or something, then maybe it's a bad idea. Do you see? Because you only have a 90% confidence. Do you see how that works? So you would talk about all that stuff in the project, which is the next thing I'm going to jump into. But one thing to jump into first, that is the secret word. And the secret word is paired. Paired is another word for dependent, by the way. The data are paired if they're dependent. So that's the secret word, and that's the reason I did it. Okay, so now let's go to the syllabus. And I'm going to look at a couple things. One is, I know it's a long time from now, almost a month, but project 2 is due March 26th, okay, which is Sunday of week 11. And we're Monday of week 8, by the way, so it's still a while. And by the way, it's due on a different day. It'll do a little earlier if you're a face-to-face student. I should mention that since we do have face-to-face here today. And that has to do with the way the course works, just a note. The material, all the assignments are mostly the same, but the dates are a little different. Okay, and who knows what will happen to the dates if Wednesday is another snow day. We'll find out if we're actually going to be here. Okay, and so far, my internet and my electricity are still working. So I haven't lost it. Okay, so now if I go to projects, I want to mention a few things. First thing is project 2 we're on. It's the same rule. You must work with partners. Okay, and I recommend 3 people in a group. You can have 2. You can't have by yourself. And you can't have 4, because 4 you can split up into 2 groups of 2 and then maybe grab another person. Do you see how that works? Same thing. And don't wait until, you know, a week before the project is due to look for a partner. That's a disaster. You should be looking now if you don't already have one. You are allowed to use the partners that you use for project 1, but you don't have to. That depends on whether it works for you. I do recommend either way, whether you're working with the partners that you use for project 1 or not, you should, if they're still in the class, you should communicate with those partners and let them know I'm looking for a different partner, so we're not working together, or yes, let's work together. So that's communication's important. And try to be polite, even if you didn't get along with your partner, try to be polite, because that's a good thing. Okay. So that's a note about the project. You're going to conduct a survey, okay, and construct a confidence interval and perform a hypothesis test. Hopefully you're not too surprised about that. Okay. Okay, so that's important. You're still going to be doing you still have to do it on a spreadsheet. So you can't use the calculator that we use for the exams, because you have to use a spreadsheet. And just a note, probably I should show you just in case. I'll probably show you again later. If I go to stats, I go here. You're not going to be using this particular tab. You can be using two variable stats. So you click on two variable stats and it's giving you different stuff. Okay, it's actually really easy to use, but you just got to, remember to click two variable stats, and it gives stats for A, stats for B. Now it's not going to read your mind and know if you meant dependent or independent data. So I just did both, and you have to know which one to look at. That's all. So you're only going to be looking at one of these, whether it's independent or it's stats for a difference, which is dependent. Okay, so focus on whichever one, and your project is going to do whichever works for you, but you have to do the right one, because you're going to describe your project. And if you're describing dependent, you better be using dependent. If you're describing independent, you better be using independent. Don't worry about this stuff. Frequency table, you're not doing that. Okay, so that's just one thing, is that you're going to be using this spreadsheet. So now let's go back. Syllabus, there it is. And I'm going to click on project 2. And I want to look through the requirements. So the purpose of project 2 is to use the confidence intervals and hypothesis testing to support or show lack of support for a research project. You must first decide what you're interested in researching and design your study and collect your data. Okay, just like project 1, you have to identify a theoretical client, okay, who will be making decisions based on the results. Okay, and again, that client could be the president of the college, it could be, I don't know, a manager of a restaurant, it could be, head of Amazon, whatever it might be. Okay, I do want to let you know that this is not project 1. Okay, so you should talk about the sampling technique, but not like a page of talking about it. Just a quick little what you did. Does that make sense? Okay, here's something different in project 1, project 2. Any technique may be used for this project. Okay, that was not true in project 1. Project 2, any technique. What's the easiest technique, by the way? Typically.
Convenience.
Yeah, convenience sampling. So you're allowed to use convenience sampling. You don't have to. If you're doing this, and once in a while I get someone doing that, if you're doing it like for your boss, then you may not want to do convenience sampling, because then you're not going to have reliable data. But if you're just doing it for me, for the project, that's fine. Convenience is fine. You just have to admit to it. That's all. Okay, any questions on that? Okay, just a note, you're collecting data and it must represent a sample, not a census. If the census data is available and easy to get, then this is not an acceptable project. Okay, so don't just pick, I don't know, maybe 32 presidents of the United States, because you could pretty easily just get them all. Does that make sense? And look at data on the presidents. So that would be an example that wouldn't be acceptable because I don't remember how many presidents we've had so far. Anyone remember? Yeah, I think we're in the 40s, maybe. I'm not sure. But the point is, it should be a very large population at which you can't grab everybody or everything. And it doesn't have to be a survey of people. Okay, you're unlike Project One, you are allowed to survey find data. So you're allowed to say, I don't know, if you wanted to compare Amazon to Walmart on products, you could do that. And just go find data, just find 31 project, things at Amazon and 31 things at Walmart. Do you see how that works? You don't have to ask people a survey question. You're allowed to, but you don't have to. And sometimes it's easier to just grab data. So the focus of this project is not the data collection. That was Project One. The focus of this project is the confidence interval and the hypothesis test. Most of your pages in the project should be confidence interval and hypothesis test explanations. Any questions on that? Okay, a sentence or two about the sampling. That's all you need. Okay, hopefully you know why this time is the sample sizes must both be greater than 30. Whereas in Project One, I just said, trust me, it was important. Now you understand why. Otherwise, you don't really have any good data to look at. So sample size must be greater than 30. And by the way, as I mentioned earlier, this has to be quantitative. Okay, has to be quantitative. So no yes, no survey questions, no qualitative survey questions. Should be a bunch of numbers. Any questions on that? And you should be looking at a survey that is actually interesting. Okay, if nobody would be interested, then it doesn't work. Okay, yeah, and just know this will be on YouTube if you have to leave early. Okay. So here's the main stuff you have to have. You have a list of the summary statistics, a brief interpretation, not as long as the interpretation of the statistics that you did in Project One. And the main ones really are the mean. That's the main one. That's the only one you should talk about, in any kind of depth. But there's one other statistic. I don't know if you call it a summary statistic, but there's one other major statistic that you have to spend a lot of time on. And that is, remember, what was it in Project One? What was one you had to spend a lot of time on? I told you I had to have a whole paragraph. Hadn't been that long since Project One. Just a few weeks. Do you remember? If you don't remember, I'll tell you. Standard deviation. Okay, for Project Two, we're going up a level. It's standard error. And I want to mention, I think I'll throw the spreadsheet at you. If you're doing independent data, it's that standard error right there. So it's the standard error for independent data. If you're doing dependent data, then it is this standard error right here. Okay, just note these are worthless. Don't even mention them. It's a mistake people make. Okay, it's either going to be this one or this, or this one. And that you're going to spend a whole paragraph on. Because the standard error makes all the difference in your confidence interval, margin of error, and your p-value. Okay, so there's a standard error by itself. There's a standard error on how it relates to the confidence interval, and the standard error on how it relates to the hypothesis test. And just a note, that's here. I made a video on the standard error because that's a problem a lot of people have trouble with. So I recommend you watch the video of the standard error. And it talks about how all those things work together. Okay. If you don't watch that video, it probably won't go well for you. Okay. So again, you should be looking at a confidence interval for the difference. Whether it's independent or dependent, that's up to you. You just have to do the right thing, you know what I mean, based on your data. But you get to choose. Okay, but it can't be a single population. I mean, it can't be a single variable you're comparing to. It's a comparison study. Okay. Just a note, you should give the reason for choosing the confidence interval. I mean, the confidence level, sorry. And that one is very, do not say, I used a 5% level of significance, so I'm going to use a 95% level of confidence. So don't do that. That's wrong. You should be looking at the pros and cons of the 90%, the 95%, and the 99%. Kind of like what I showed you today in the example. Okay, remember the pro of a 99 is that it's very unlikely that you're wrong. The con is that you have a bigger margin of error. And you don't have very useful information, possibly. Okay. The pro of a 90% is that you have a much smaller margin of error. So you have better information. The con is that there's a 10% chance you're wrong. Do you see? And the 95% is like the middle of the two. Okay, so you should be looking at it, you should be writing about all of them and then making your decision on which one to use and then interpreting the one you use. Do you see how that works? Okay. And again, you should explain the ramifications of the population mean difference not lying in the interval after the new decisions are made. Okay, and this is the person that you're writing to is your client, not me. You can't assume, even if it's false, that your client understands statistics. Otherwise, the project wouldn't even work. So you could pretend the client understands statistics, even if, it may not be true. Got it? Okay, you also must have a hypothesis test for the difference and its interpretations. You just do it in order. And this is really important that people don't realize this. Remember, there was an order at which you do a hypothesis test. First, you decide on H0 and H1. Second, you look at the level, you look at the type 1 and type 2 errors. And when I say order, that's the order at which you should be writing your paper. Okay, don't write about type 1 and type 2 errors and look at both of them after you've already seen a p-value. The type 1 and type 2 errors should be done before you even get data. So then, based on the type 1 and type 2 errors, you decide on your level of significance based on which is worse. And if they're the same, remember, you use 0.05. If type 1 ramifications are worse, you use 0.01. If type 2 ramifications are worse, you use 0.10 or 0.1. Okay. So then, after you've talked about your level of significance and the repercussions based on it, then you go grab your data. Okay, but actually, before you even grab your data, what might you do? What do I strongly recommend you do before you get your data? Hint, project 1. Any thoughts?
The survey question?
Yeah, but well, no, you can't really have a survey. You can't talk about a type 1 and type 2 error unless you know the survey question, right?
Yeah.
Yeah. That's all part of the, null and alternative hypothesis, actually. Should I tell you? You posted on the project 2 discussion board. and I'll let you know if it'll work or not. Do you remember you had to do that for project one? Yeah, that was recommendation for project one also. But if now you go to your discussions, you'll see a project two discussion. And that's where you post it. And I'll take a look and give you suggestions. So you should post your survey question, your hypotheses, and how you're going to collect your data. Okay. Then once you've done that, and I've said, hey, it looks great, or it looks almost good, but change this one little thing, then go and collect your data. And you shouldn't have to spend too much time collecting your data. Sometimes it's just going online and looking. Might take 10 minutes. So again, it's convenient sampling, so it shouldn't take long. You don't have to do a survey of people. Some, you can, but you don't have to. You can just, go find stuff on, online. But again, if you can find the whole population, then it won't work. It's only if you can't get the population, but you can get a sample. So good luck trying to find the cost of everything at Amazon. But you can find 32 things very easily, right? Kind of like that idea. Okay. Any questions on that? Then the next step after you've collected your data is you put it in the spreadsheet. And then you do your write-up after putting the spreadsheet. So just note, this is not project one. You don't need to have any charts. Like you don't have to have a pie chart or histogram or stem and leaf. None of that's necessary. Okay, this is not project one. This is all about the hypothesis test and the confidence interval. Okay, so that's important. Okay, and then after you've done your write-up, what should you do next? And you mean y'all, you partners. Hint, project one. Should I tell you? Email me your draft. Yeah, and again, if you don't do that, I'm not going to be able to tell you what went wrong and what went right. If you wait until you're submitting, then I'll tell you what went wrong and what went right, and you'll lose points for what went wrong. Do you see how that works? Or for what you left out. Okay, so if you send it to me in advance, I can let you know what went wrong, what went right, and help you out. Okay, same rule as the last project. You need to get it to me by the Wednesday before.
So is that the 22nd?
I don't have the calendar in my brain, but I can look.
Okay.
Yeah, it's the 22nd. There we go. But again, first come, first serve. So I don't recommend waiting until, last minute. Actually, Tuesday at 8 in the morning is allowed, but better would be like, when Thursday at 8 in the morning is allowed, after 8's not. But better would be like, Tuesday or Wednesday in the, not late, but Wednesday morning or something. And that's a recommendation. That way I can look at it, get you feedback, and you'll have plenty of time to work on the feedback, maybe get help from Braulio or any of the other tutors and make that happen. Okay. And then the next step is to fix the problems that I found and let you know of. And then the final step is the same as project one, which is
Turn it in.
turn it in. Yeah. In the same way, don't forget your names need to be on the project. That's not too much to ask, is it? It's good to have a title. And you turn it in. I recommend turning it in by Saturday instead of Sunday. And that way, if things go wrong, you have that extra day. That's a good life skill, by the way. If you have something really important, don't wait till the last minute. do it a little bit early. Because really, honestly, whether it's Saturday or Sunday, it's not going to change your life, right? But if you turn in Sunday, you have stress, more stress. And why should you have more stress when you can be a little more relaxed? So if you kind of force yourself like one day earlier on doing everything, that helps. And we're talking about like almost a month. So almost a month minus a day versus almost a month is almost the same thing. And you now have all the information you need in terms of statistics to do this project. So if we're going to learn new stuff next week and the week after and the week after that, don't put any of that stuff in. One more thing that I forgot to mention. After you've looked at your p-value and made your conclusion, you should decide whether a new study with a bigger sample size based on this to decrease the standard error is a good idea. And after you've looked at your confidence interval and interpreted it, if a new study with a bigger sample size so that you can decrease your standard error, which decreases your margin of error, is a good idea, is worthwhile. And again, if you're real happy about your confidence interval and you're able to go 99% and you still have really good information, you don't need a bigger study. Do you see? But if you look at it and you say, well, I had to go to 90% because I needed the margin of error to be smaller, that's when you probably want a bigger study. Do you see? So you can really have a 95% at least of confidence. Okay, so that's about it. And I always like to end it around 7:40 if I can, especially when I have something big to talk about like the project. So I am going to stop the recording.